Welcome to Flip Classroom. Our topic today is statistics, and we are looking at surveying and sampling. Our learning intention is we are learning about the importance of surveys, and our success criteria is I am successful when I know the meaning of population, sample, survey, and census, understand that a sample needs to represent the larger population for conclusions to be meaningful, and I am able to identify symmetric, skewed, and bi-modal data. For this video, I want you to find a book, open to a random page, and look at the first 10 words and work out the average of those 10 words. Then I want you to find a different page and work out the first 20 words and find the average for those ones. And then look at a third random page and look at the first 30 words and find the average length of those words. Now I want you to think which of those three options are the most accurate to represent the average word length in the English language. And is there an advantage or disadvantage against doing each of those options? So our key words are population, and population is the set of all members in a group that's being studied. So I could look at a population of a country or a state or a town or a school or a year level. So the populations can be anything from as large as a country or even the world, all the way down to something as small as a year level or a class. We can also look at other populations of creatures, such as population of animals in Port Phillip Bay. We can have a sample. Now, a sample is a smaller set of the population, and we call that a subset of population. So an example could be just one class out of a year level, or 1,000 people selected at random from a phone book or some list. Next is a survey. Now, a survey is used to collect information about a population, and it's usually done with a small set or a subset of that population. So I might go into that one class and do a quick survey to find out what the year level thinks. And finally, a census is similar to a survey, but you do it across the whole population. So you might do a census in the school and every student has to respond to the survey. In Australia, we have a census ran every 5 years. So there's one in 2021, there was one in 2016, and there'll be one in 2026. When taking a survey's accuracy and conclusion can be affected by lots of different things, one of which is the sample size. So if I take a survey and the group is too small, it may not be accurate enough for the whole population. So this might be surveying just one class out of 40 or 50 classes in a school because the population might be too small. Or it might just be a survey of a small group of people when you need a diverse group, including different religions, genders, and ethnicities. Now, a biased selection or biased questions are when the survey is done in such a way that it could influence the people who are being surveyed, or it could be that I'm being selective as to who I'm surveying, and that might change the outcome of the survey. So an example would be if I wanted to find out Australia's favourite song, and I only surveyed one group of people, such as 1 year level at a school. Obviously, I might find out what someone in that age group might think of their favourite song, but I wouldn't be getting anyone outside of that group. So if I wanted to find out Australia's favourite song, I'd have to survey a whole group of people ranging from different ages and different backgrounds. And finally, measurement errors. And finally, we have measurement errors. Now, this could be where a question is unclear and people are just taking a guess as to what it means, or it might be where people are not answering questions accurately. They may just be selecting random responses or selecting all the same answer for every question because they just want to get out of the survey. Now, this can cause the measurement to be what's called an outlier. So if I've got a person who has selected all of the positive answers without actually reflecting on the questions, it could mean that their data is invalid and might have to be removed. And the same goes with questions. So if a question is unclear, we should remove that question from our survey when analysing that data. Once you've done a survey, you might want to make a graph of the data that you've collected. And if you're not sure about doing some of the graphs, you might want to look back at describing histograms or drawing graphs, and the card is in the top corner. There are some graphs that have specific names or specific styles. So we have what's called a symmetric graph, and you can see that the data on the left and the right kind of go up at the same rate and end up at a peak. There can be a little bit of fluctuation, but generally it's equal on both sides. Bimodal data, this is where you see two modes, where there are two answers that are most likely. And finally, we have skewed graphs. This is where the majority of people think one way or the other. So it can be skewed both negative and positively. Now the skewed negatively is actually on the left because it's got the mode on the right hand side and it's got that long tail going to the left. And skewed positively is actually on the right down the bottom. And that's where we've got a mode that's on the left hand side and it's got that long tail going off to the right. Now for data that's symmetrical, the mean and the median are approximately the same value. So it'll be fairly much in the center of that information. So here's a worked example. We have a survey that has asked 100 randomly selected adults how many children they have. And here's our graph. You can see that there are 35 people who had 0 children, 20 people had 1 child, 20 people had 2 children, 15 people had 3 children, and 10 people had 4 children. Assuming this sample represents the population, what proportion of adults in the population have 2 or more children? And in a group of 9,000 adults, how many would you expect to have no children? Question B is this distributed symmetrically or symmetrical? Is it skewed or is it bimodal? And question C, which of the following ways could lead to bias? So if I did this survey while waiting outside of a school, if I did this survey at a nightclub on a weeknight, or if I picked 100 people from the national census. Now, because this is such a big question, we're going to break it up a bit. So let's start with question A. I'm going to have my thinking on the left and what I would write down for my teacher on the right. So first off, I will have a look at the numbers and work out how many people said that they had a child, because the question is asking at least one child. So I'll have a look, I'll add up those numbers. So we know that it's 20 plus 20 plus 15 plus 10. We add that up and we know that 65 adults had 2 or more children. Now we know this is out of 100, so I'm going to place it into a fraction and then I need to simplify it. So the fraction of adults is 65 over 100 because it's 65 out of 100. And if I simplify it, I can divide the numerator and denominator both by 5 to get 13 over 20. And that's my answer. So the next one is, how many people do I expect to have no children if there were 9,000 adults? So first off, I will find the fraction of people with no children. Now I could use the answer above, but I'm going to start from scratch. So in the survey, I have a look. There are 35 people with no children. So that's 35 out of 100 or 7 over 20. And then I'm going to multiply that fraction with the number of people in our population. So the number of people in our population is 9,000. So I'm going to go 7 over 20 times 9,000 and I get 3,150. So in my book, I'd write, based on the survey, we would expect 3,150 people to have no children. So for question B and C, is this distribution symmetrical, skewed, or bimodal? So if we have a look at the graph, we can see that there are a lot more people on the lower values than the upper, and we've got that long tail tapering off to the right. So we will say that the graph is skewed. Next question is looking at ways that could lead to bias. So to start with, that first one, if I was asking people waiting outside of a school, it would be biased because those people would be waiting for their child. So obviously, most people there would have at least one child. For method 2, asking people at a nightclub on a weeknight, well, people at a nightclub on a weeknight may be younger adults and therefore less likely to have children or would have less children. So that could be a little bit biased or skewed the data as well. The third one, picking 100 people at random from a national census, as long as it is truly random, it wouldn't be too biased. So both methods 1 and 2 could lead to bias in the surveys. So for your reflection, I want you to think about why it is important to know the source of the data and also what type of questions were asked in a survey. As always, like the video, subscribe to the channel, and come back for more videos on maths.